Many 2x1 marks are required to implement the half adder. So we know in case of half adder we have two inputs A and B and two output, that is sum given as A XOR B and carry that is equals to A dot B. So let us implement this. So to implement the half adder we have to implement one XOR gate and one AND gate. So we need to implement XOR gate and AND gate. So as we have already seen, to implement the XOR gate we need a 2x1 marks, in which if we give select line as A, then input should be given as B and B bar. So output will be in this case A XOR B. Similarly, if we want to implement the 2x1 marks as AND gate, so we need to apply select line as A, and this should be applied with 0 and B as the input. So we will get output as A dot B. So here, how many 2x1 marks are required? This is one and another one. But here, we don't have B bar present already. So we need to implement B bar also. Okay, so for B bar, we need to implement using a NOT gate, and NOT gate can be implemented using a 2x1 marks if we give select line as A and input as 1 and 0. So how many marks we need? We need basically 3 marks. So we need 3 2x1 type marks to implement the half adder. One marks will be required to implement the AND gate, 1 marks and 2 marks will be required to implement the XOR gate. Because we don't have this complement, that is B bar, to implement B bar we need another NOT gate. So option number 3 will be the right answer. A 4x1 marks used to implement 3 input boolean function as shown below. The boolean function A, B, C implemented is, so we have to write down the expression of function. So here we are using a 4x1 marks which is having select line S0 and S1 as B and C, and inputs are applied like this. So let us write the expression of output for this. So output will be S0 bar into S1 bar into A plus S0 bar S0 into S1 bar into A bar, because here we are applying A bar and here we are applying A, plus S1 into S0 bar into 1 plus S1 into S0 into 0. So we have written the value of I0, I1, I2 and I3 over here. So this will now become, if we put the value of S0 and S1, this will be B bar C bar A plus B bar C A bar plus B C bar 1 plus B dot C into 0. So let us rearrange this. We can write it as A into B bar C bar plus A bar B bar C plus B dot C bar, and this is going to be 0. If we have to convert this standard form into canonical form, what we can do, we can multiply here by 1. And we know A plus A bar is equals to 1. So we can replace this 1 by A plus A bar. So this will now become A into B bar C bar plus A bar B bar C plus B C bar into A plus A bar. If we open the bracket, what we will get? We will get these two terms along with A dot B dot C bar plus A bar B C bar. So how many minterms are there? So we have, this is minterm M4, this is minterm M1, this is minterm M6 and this is minterm M2. So we have minterms, so we can write it as a summation of minterm, as summation of minterm 2, 1, 2, 4, 6. So that is the expression of function A, B, C. So from the given option 1, 2, 4, 6 is the right answer. The first option is going to be right. answer. So as you can see, we can implement any given function using a 4 cross 1 mux. Let us now see how to implement higher order mux using 2 cross 1 mux or lower order mux. Suppose we want to implement 4 cross 1 mux using 2 cross 1 mux. So for 4 cross 1 mux, we should have 4 inputs, but we have 2 inputs in 2 cross 1 mux. So what we can do, we can cascade 2 cross 1 mux like this. So suppose this is a 2 cross 1 mux which is having 2 inputs and single output. So what we are going to do, we are going to apply input I0 and I1 and I2, I3. Okay, so both the mux are applied with the same select line as over here, and output of these 2 mux will be applied to another 2 cross 1 mux, which will generate single output. And it also need a one select line, so this is S0, then this is going to be S1. So depending upon the status of S0 and S1, the output Y will be I0, I1, I2 or I3. So if we use 3 mux, that is 2 cross 1 mux, we can implement 4 cross 1 mux because it is having 4 input and single output. So how many 2 cross 1 mux are required to implement 4 cross 1 mux? That is 3. Suppose we want to implement 8 cross 1 mux using 2 cross 1 mux. So how can we do that? For 8 cross 1 mux, we need 3 select lines and it is going to have 8 number of inputs and single output. So what we can do, we can connect different 2 cross 1 mux like this, and each mux is having 2 inputs. Output of these mux can be applied to another mux. Similarly, output of these 2 mux can be applied to another 2 cross 1 mux, which will generate single output. Again, this output can be applied to another mux. So in this manner, how many mux we actually require? This is going to be I0, I1, I2, I3, I4, I5, I6 and I7. So we have in total 8 inputs, and here we are getting single output. So that is the function of 8 cross 1 mux. So how many 2 cross 1 mux we require? That is 4 plus 2 plus 1, that is equals to 7 multiplexers of 2 cross 1 size are required. But if I say how many 16 cross 1 mux are required, if we want to implement 16 cross 1 mux using 2 cross 1 mux, then how many this kind of multiplexer are required? Then this procedure becomes quite complicated. We can't do this in this manner. So for that, we have another approach to solve that. Okay, so this method is going to be different, in which suppose we have to implement 16 cross 1 mux using 2 cross 1 mux. What we are going to do, we will divide 16 by 2. Then we will get 8. Then again we divide it by 2. We will get 4. Again we divide it by 2. Then we will get 2. And again we will divide it by 2 until unless we get a ratio 1. So here, as we get a ratio 1, we will stop here. So this is going to be 8 plus 4 plus 2 plus 1. Add all these, so we will get 8 plus 4, 12 plus 2, 14 plus 1, 15. So we need 15 2 cross 1 mux to implement 16 cross 1 mux.